So, welcome everyone. Can everybody hear me correctly? Yeah, okay. I'm Roland, also known as the tall guy from the Netherlands. And I'm working in the Netherlands on several projects, mostly Microsoft, doing web applications. And one of the fields I'm working in is the security of web applications. And I want to tell you something about that in the context of OAuth2 and OpenID Connect. So, what we're going to do first is address the problem. So let's see what the problem is with the current state of affairs. Oh, can you just close the door? And then we go. Well, I just have 40 minutes, so I'm trying to do the best I can, but there's a lot of ground to cover with this topic. And then we'll see how it works. I think these are the most important things to cover. And then lastly, if I have time, I will show you some demos. But 40 minutes is not too much time, so we'll see. So let's start with a typical scenario. So we're not talking about OAuth2 yet. We're talking about the situation you might encounter in the current project you're doing, or some security scenario you came across earlier. So let's say the user is me. And I'm using a browser. It's not, well, half of me. I'm using a browser. And that browser maybe is connecting to some kind of web server. Well, because I'm a Microsoft guy, I took ASP.NET right now. How many people are using ASP.NET? And how many people are using Node? For example, other stuff? Okay. Okay. Cool. Doesn't matter what's here. I just took ASP.NET, but you can take any kind of other platform. Well, the browser talks to ASP.NET, to a server, of course. And then I have to authenticate with that application. So I get a login screen. And I type in my username and my password. And what the application does, it checks somehow in a database if my credentials are correct. That's a typical scenario, but it doesn't feel right anymore in nowadays, in modern applications. And I will show you why that is. It's first and foremost, it's not very handy to implement security time and time again in every application. And the user has to log in with some specific username and some specific password in every application. So I have to remember all these passwords. So that's not very nice for the user. But we also live in a world where we have applications that more or less do the same, but on a different platform. For example, well, I showed you ASP.NET or some other platform. This is the logo for Cordova. So it's a mobile app. And we have maybe a Windows app or a Linux app or an iOS app or whatever. So all these applications more or less do the same. Think about Facebook. You can read Facebook messages on many platforms. On your phone, on Windows, whatever. In a website. So all these applications talk to the same backend. Well, I've put on Web API here. There's also a Microsoft product. It's just a Web API, some sort of service. All these applications talk to. So the old scenario I showed you earlier, that every application has its own login page, well, it doesn't work very good anymore. Also, it gets more complicated when these applications not talk to one API, but to several APIs. And that's also getting more and more common. Also, well, we live in a world where users are used to have, well, some credentials, some login credentials that they remember that are well known to the user. For example, everybody knows how to log in to Facebook or to Twitter. And you don't want to have your own credentials in your application. You want maybe to use these credentials as well. So a user can log in your application using Facebook. Well, it turns out OAuth2 does a great job of integrating all these identities on the internet. So, what is OAuth? Well, the simplest way to talk about OAuth is when you go to a hotel, you get a room key. And with that room key, you can access the entire building and the hotel, but only the areas you're supposed to be in. So you can enter your room, but you cannot enter the room of your neighbor, for example. But you can go to the fitness center. It works, the key works on the fitness center. But there are also people in the hotel, working in the hotel, that have a key that works on every door. So the key represents a limited set of what you can do. And that's exactly what OAuth provides. So OAuth provides a way to have a room access key, an access key. We talk about keys later. Well, it's called a token in OAuth2. And that token provides access to the API in some kind of limited way. So that's what it does. So, the simplest way to talk about OAuth2 is you get tokens in exchange for a secret. Well, the secret can be a password, but it doesn't have to be a password in the OAuth world. But when we talk about user interaction, and that's what this talk is about, we talk about a password, but it can also be a certificate, for example, if there are no humans involved. Okay, now what is OpenID Connect then? Well, OpenID Connect is a layer on top of OAuth. OAuth is just about, well, the limited set of access you gain to the servers, but it's not about identity. So when you have to know the identity of the user, not what he can do, but who he or she is, then you use OpenID Connect on top of OAuth2. And it's very convenient because if you know OAuth2, you already know OpenID Connect. It's just more of the same. It adds a layer to OAuth2. And what you can, well, you can picture OpenID Connect as some kind of passport or driver's license you have. So it proves who you are. Right? And you can picture, well, on this card, there are many, all my stuff is on it. My whole private life is on the card. And OpenID Connect can ask you for, well, would you give me your email address and your name? And you consent to giving that information to the application. You know the consent screens you get from Facebook when you log in via another application? Well, that's the stuff you release from the vault, so to say. And that's the whole thing of private information that's on your card. So is this clear? What the difference is between OAuth and OpenID Connect? Any questions so far? Okay. So here's the graphical representation. OpenID Connect is on top of OAuth. OAuth is about authorization, what a user can do. It fetches tokens, and OpenID Connect also fetches tokens, but it adds authentication. So, what players do we have in the OAuth world? What do we have to know about OAuth? Well, there are 4 roles, so to say. There is a resource owner, and the resource owner is a human. The client, and the client is some application that's running on my phone or in Windows that talks to the back end. We have the resource server, that's the web API I showed you earlier, that has the resources. And we have an authorization server, and the authorization server is separate from your application. So earlier, the first slide I showed you, was the authentication was integrated in your application. Now we delegate the authorization to another server, to another application. So OAuth2 is about delegated authorization. So we talk to another server to do that. I will show you in a minute how that works in a flowchart. But first of all, let me illustrate how that cast could look like. Well, maybe the resource owner is me again. This time the whole me. And maybe I want to, well, I have an idea that this weekend I'd like to watch Breaking Bad the whole weekend. And what I want to do is, well, just sit on the couch, turn on the television and watch Breaking Bad. Well, maybe season 1 and 2, full episodes. That's my plan for this weekend. So, the resource owner is me, the client is my television. I look at the television. The resource server could be Netflix. You know Netflix in Italy? Okay. So Netflix is the resource server. That's where the stuff comes from, and the television just, well, uses Netflix to show me the content. And the authorization server, of course, she's not here right now, but it's my wife. And my wife, she's not very happy about my plans. So my wife says, well, no. You don't get permission to access that resource. So I don't get a token to access the resource in the OAuth terms. Well, let's say I change well, the proposal a bit, so it's me again. But now I'm looking on my iPad. So I'm sitting in the garden and I can look after the kids and while I'm watching Breaking Bad. And well, I have some other provider that has a website that provides the Breaking Bad stuff. And again, the authorization server is my wife, and she says, nope. Because it's not a very good idea. You have to watch the children, yeah, right? Make sure they're okay. So I say, well, okay, I will just do it for 2 hours then. Only on Saturday, between 4 and 6, I will watch Breaking Bad. And she says, okay. So I get a limited access to that resource, only between 4 and 6. That's the whole idea about, of OAuth. So the cast is, the resource owner is a human, the client is some application that is ASP.NET or whatever. We talked about it earlier. It can be everything. It can be a Windows application, OS 10 application, doesn't matter. And it talks to a backend called Web API, and that's the resource server. And the authorization server is a different product running on a different server. And the thing I used here when I come to the demos, well, maybe I show you Identity Server 3, which is a .NET implementation of OAuth2. So OAuth and OpenID Connect use tokens, and tokens are credentials for the resource server. So the resource server doesn't get a username and a password, because only the authorization server gets the username and the password, but it only gets the token. And the resource server can validate that this token comes from a certain authorization server, because it's encrypted with a private key. The public key is published, so it knows for sure it is created by a certain authentication server. So that means the web API trusts the resource server. On that basis, it decrypts the key. It knows, okay, that's resource server, so I trust it. And in the token is what I can do. and what client I am. So on that basis, it provides a certain kind of access to the resources. Are you still with me? Yeah? All right. So it also enables single sign-on. And single sign-on, well, that same kind of token could be trusted by other applications, because they trust that authorization server as well. So I can send that same token to another application, to another resource server, which is also okay with that token. So that enables, as a side effect, SSO. So what's in a token? Well, it contains claims, and claims is information about the user when you use OpenID Connect for identity. And a typical thing about tokens is also that they are expiring, so they have a limited lifespan. And that's configurable with the authorization server. And that basically means that maybe it has an expire time of, let's say, 30 minutes. So you can use that token for 30 minutes to access that resource token. All tokens expire in that way. That also means that if the token expires, you have to do the whole thing again with entering the password and stuff. That's not very handy and not very convenient for the user, because it will irritate him for sure. So they thought of another thing, and that is a refresh token. So that's another token. And that refresh token, you can use that refresh token to get another token that expires in 30 minutes. And so you can extend by using refresh tokens. I will tell you more about that later. So with OpenID Connect, there is a certain kind of token required, and it's called a JWT, JWT. And JWT is a JSON Web Token. So it means JSON Web Token. And that's easy because JSON is parsable by every platform. OAuth2 itself doesn't have a specific token format. If you read the specification, they don't mention a specific format. So it's possible that OAuth2 is implemented with another token format, but mostly now with the great providers like Google and Microsoft and Amazon and stuff, they all use JWT. So what's in the token? Well, it's JSON, so it's curly braces. It has a header. It says, well, my type is I'm a JWT, and I'm using a certain encryption algorithm. And in the body is the subject, and the subject is the Homo sapiens I talked earlier about. When you log in, for example, with Google, the application gets back a number that's unique for you. So so I can easily correlate that number to you. There's an audience, and the audience is the client. There's also when you ask for a token to an authorization server, you have to provide which client you are, a client ID. I'm client iOS app, for example. And that client ID is also available in the token. So the resource server knows what client is accessing it. The issuer, so that's the URL to the authorization server. Expiration, we talked about that. And I'm not going to cover everything it's here, but we have a scope. And the scope is like the roles I want. What do I want with this application? Well, a very simple example is I want read and write access. But you can make them up yourself if you want. You can say, well, I want customers. So I put customers in here. So the authorization server knows about scopes. So it checks the scopes you are asking to the configuration for that client, if that scopes are allowed. If they're not allowed, you get an unauthorized error back. And when the token goes to the resource server, it also sees the scopes. So it knows what kind of access to provide to that user. Okay, so now to OAuth flows. Flows are, they're just scenarios that are supported, basically. But there are scenarios that are more handy for. There's three. I talk about 3 flows here, and they're just flows for users, for humans. There are also 2 or 3 other flows that involve, server-to-server communication, for example, when no human is involved. So I'm not talking about those here. I'm just covering the user scenarios. The first one is authorization code. This is by far the most used flow in OAuth2. And that's because this flow supports refresh tokens. And the other one I'm showing you doesn't. Well, it's me again. And I'm using a browser. And first, what I do is, well, let's say my application, my client is an ASP.NET application again. So I type in a URL in my browser, goes to that URL, and my application says, well, you don't have a token, so you don't have access. So what it does, it redirects automatically to the authorization server. It knows what the authorization server is because it's configured with that URL for that authorization server. So it redirects to that authorization server. And the authorization server says, well, I show you a login screen. Give me the secret. So you type in the secret and you get the consent screen. Well, it's a bit small, but the Google consent screen says, well, this application XYZ wants your username and your email address. Do you think that's okay? You said, okay. Then what the authorization does is it gives back a code. So not a token, a code. And the code is used to get the token. So the browser, it's called the user agent in the specification terms, is sent to the client. And the client receives the code. And the client then uses the code to get the token. So what's the whole fuss here with the code and stuff? The whole point here is that the user agent, the browser, never gets the token. So that's a security measure. The token is never known in the browser, just the code. So you cannot do fancy stuff in the browser to get the token and decrypt it or whatever, because you don't have the token. So the token is fetched by the client, and then the token is used to access the resources. Right? So then we have the implicit flow. The implicit flow is a simplified flow. So now we don't have a token. We use some kind of client. It uses the authorization endpoint. And now I have provided some request information, so to say. So we have the same flow. We have the same flow again. The client accesses the authorization server with a redirect. And it does that by doing a get on the authorization URL, authorization server URL. And it says, I'm client this and that, and I want a token. Response type is token. And the authorization says, okay, who are you? And then the consent screen is shown, and the token is given back. So now we have the token in the user agent. So that's deliberate. This is done for simple clients, like, let's say, a single page application where you have a JavaScript in your browser that runs everything. It's not very handy to get the token first, or get a code first and then get the token. Just get the token directly. But it's limited because implicit flow doesn't support refresh tokens. So when the token expires, you have to do the whole thing again. So that's not very handy. It's simpler, but... So we also have the hybrid flow. The hybrid flow is a combination of the two. So you can either get the code and then get the token, or directly get the token. So now you have an endpoint in the authorization server that supports both. So when you have several clients, you can just pick and choose what you want. What's the time? We have... Yeah, right. Until 1, right? Yeah. So what does OpenID Connect bring to the table? An extra token. So OAuth provides an access token with the scope stuff and what you can do. And OpenID Connect, when you enable that, it provides an extra token. So a separate token from the OAuth token, which contains your personal information that is requested. And it defines several built-in scopes. So one scope is OpenID. When you do, so let's go back to the slide. Here we say, well, the response type is token, client ID is that. One of the scopes you can request is OpenID. So with OpenID, you say, well, I want OpenID Connect on top of my OAuth, so I want 2 tokens. And what you want is also provided in the scope, and that's profile, email, address, phone, and there are several more. What OpenID adds to the authorization server is an identity and a user info endpoint. The identity endpoint is used to get the ID token. And the user info endpoint, well, maybe you want all this information from the user. Favorite color, birthday, all that kind of stuff. Then you can imagine that that token is getting very big. Maybe it's his or her photo or whatever. The token gets too big. So a token is issued that provides access to a user info endpoint where you can get that information separate from the token. So that's the user info endpoint. And it has a discovery. And the discovery is provided at a well-known URL. So that's just a URL every authorization server uses. And in that, on that URL is a piece of JSON that says, well, my public key is here. I used it. You can ask me for these and these scopes, etc., etc. So it's a discovery. And the beauty of the frameworks I use, for example, but this is a .NET framework, but you can also use other frameworks, is that they can configure themselves automatically. You don't have to worry about certificates and installing a public key, installing a certificate, because you just say, well, this is the URL of the authorization server, and it knows, well, okay, then the discovery endpoint is here, so I can configure myself. Gets the public key, etc. So refresh tokens have another scope, and that's the offline access scope. And this is a very special access to the application because you can ask for another token indefinitely. You can say, well, in 2 years, the user still have access to the application. So the resource server has a special kind of treatment for these tokens because you can revoke them. All the authorization server, almost all authorization servers, have a web page that says, well, you have given these permissions to me I'm playing Clash of Clans here. So Clash of Clans has I've issued a refresh token. It's not on the page. The term refresh token is never on the page, but it has issued a refresh token to this application. So it has indefinite access to your information. And it says what kind of information, hopefully you can read it in the gray here, it has access to. So the scopes. It lists the scopes here. If I don't want it, anymore, I can revoke the access on the Google web page. In this case, it's the Google web page. Right? So that's only for refresh tokens. So let me show you some demos. I have 5 minutes left. So here we have the... Well, I don't think I have time to show you the code itself, but I can show you the identity server. So here we have identity server. This is just one identity server, and it just have a normal URL like any website, and you can show the discovery document I told you earlier about. It's just a piece of JSON that provides, for example, the JSON web token URL. On this URL is the public key available, and the authorization endpoint URL, and what kind of scopes are supported. Here's the scopes supported. These are the scopes that are supported by my authorization server. So the client can auto-detect what it can do with this authorization server using the discovery endpoint. And it has the revoke application permission webpage, which lets me log in with Bob and a very secret password of 3 characters, which is also Bob. And well, I don't have any permissions given right now, but it's the same page as Google showed me, but now on my own authorization server. So maybe you ask, well, what about when I want to support Facebook or Google or whatever? Then you have to establish a trust relationship between your authorization server, this one, and the other authorization server. And this authorization server gets a token from the Google authorization server. It trusts that, and it somehow correlates that token with the users that are available here. So I have another identity with Google than I have here, but let's imagine users are in a database here. I could say, well, the subject, so the unique user ID from Google, I store with that user in my database. So the next time the user logs in, I recognize him as a Google user, and I let him log in with Google. And from that point on, it just issues a token like it did before, because it trusts Google and it trusts that identity. So this is the authorization server, and now we go to the client. Let me start that. So here I have a simple Windows client. Well, simple. It's a good example, so you can see how it works. So it knows the URL of the authorization server, and I can press, well, let's say, log in with profile and access token. So I'm Bob again. Log in. So here's the consent screen provided by the authorization server. And it says, well, this application wants your user identifier, which is the sub I showed you earlier in the token. And it wants your user profile information, like first name, last name, etc. And the scopes, they're not called scopes here, but there are scopes, is read data and write data. Do you want to allow that? Well, I say yes. So now you can see what comes back from the server. It's a whole stuff of gibberish because it's encrypted. But we know the public key, right? It's on the discovery endpoint. So this client reaches out to the authorization server, gets the public key and decrypts it. And you can say, well, show me the access token. And you can see it's a JOT. So it's JSON. We have a client ID, a scope. We see all the stuff that I showed you on the slide earlier. But I also have an access token. Wait a minute, did I show you the access token? Yeah, I already showed you the access token. I also have an ID token. And the ID token has the information about the user. So when I press call service, it now sends the token to the resource server which I don't have the time to show you, and it gets the result back. And these are the claims. You can see the scope OpenID, scope profile. It just echoes back the claims that are in the token. That's the whole purpose of that resource server. Okay, so we're 5 minutes from the end, and let's say we do have more slides. Let's see. No. Well, if you want to have more info, I will provide this slide deck on the USB thingy, so you will get it. You can get it afterwards. What I recommend when you really want to go into this, read the specifications. Well, it sounds very dull, but it's okay. It's readable. One is for OpenID Connect, and the other one is for OAuth itself. And when you want to go play with Identity Server, which is open source, if you are into .NET, you can find that stuff here. So, thank you for this talk. We have time for questions.
In which way your identity server can be trusted from Google?
Okay. The question is, in which way can your identity server trust Google authorization server? Well, it just acts as a client for the Google authorization server. So when it shows you the login page, you get an extra button as a user, login with Google. When you press that, it redirects to the Google authorization server. Enter the credentials there. It gets a token back.
In direct way. But
yeah.
If I go on your authorization server,
Yes.
is there a way to have two authorization servers, your and Google, and both authorization servers are trusted?
Yes. Well, you could do that, and then you have to. Well, in your web API, in your resource server, you have to trust both authorization servers. But it could be confusing for the user because it's used to getting one login endpoint. So you have to think about that. But it's possible.
So, what we did before was setting the username, maybe username and the hashed password.
Yes. Yes.
What we should store now on our server.
Exactly. Well, you still store the username and the password like before, only not in your application, in the context of your application. You store it in a different application, and that's the authorization server. So it has its own database, and it has the hash password and the username. The whole point is that you can use that authorization server not only for that one app, but for many apps.
And what about if the authorization server is not my own?
Yeah, that's.
For example, the Google one.
Yeah.
What I store in my server to always keep the user refreshing is it only the refresh?
Oh yeah, yeah. I understand. So when you don't need extra things on top of the Google things. So Google supports, for example, the email address and the profile and the username, for example. And you don't need anything else. You can just directly use that authorization server. Then you get the subject back that unique code I showed you for the user. You could store that in your database with some extra stuff that's specific for your application.
Thank you.
You're welcome. Other questions? Okay, thank you. Have a nice day.